All right, so today we're on 13.3 on integration by parts, and that's really the whole thing about this section. So that's what we're going to learn about. So what is the integration by parts formula? So what we have is we have this formula, integral from of u dv equals u times v minus integral of v du. Now this formula is really used because what happens is our integral on the left is very difficult or basically impossible to integrate with our normal integrals that we've been using. And so what we do is we're going to choose our u and our dv with care to make the integral on the right much easier to integrate, and so it'll be easier to do. Now what happens sometimes is you start with something that's very complicated here, and you get this piece that's really easy, but then this piece is also complicated, so you have to repeat the finding the u and b and du and db, and then you make it to the next line. And so depending on what your u is, sometimes depends on how many times you have to do this integration by parts. Sometimes once, sometimes twice, sometimes 3 times. So that's going to be kind of a key, that it's not just always the first time you're done. Sometimes you have to do it multiple times. All right, so here we want to find the integral of x e to the 2x dx. So with these, a lot of the times what we're going to do is there's some standard formulas, and we're going to usually, when we have an x e to some power, we're going to choose the x as our u. And so we're going to let u equal x, and so du is equal to 1, the derivative of that, times dx. Now, if we do that, we have that. So what's left is this part, so that's our u. So now we're going to say that this is going to be our dv. And so dv is equal to e to the 2x dx. And now we need to find v. Well, how do we find v? Well, we integrate both sides. So we do that. That's going to be v on the left when we take the antiderivative of the derivative. And when we do this, we're going to have to say, well, u is equal to what? 2x. du is equal to 2 dx. So that's going to give us what? Well, that's going to give us a 1/2. And then we're going to have the integral of e to the u du. And so we integrate that, and then we're going to have 1/2 e to the u, but again, u is 2x, and so that is going to be what our v is. So now we've got v, and we've got u, we've got du, and so now we can plug that into our formula. Remember, it was u dv equals uv minus integral v du. So now we've got u over here, we've got v over here, which is this one. Let's say that's our last one. And we've got the v again, and then we've got our du. So now we just plug all that in. So we have u is x times then e to the 2x over 2 minus, now we have integral of e to the 2x over 2 dx. Okay. Well, now we can pull that half out in front. So this piece is done. So now we're just going to work on this side here. So now we have a minus 1/2. And if we let u equal, guess what, 2x, and du is equal to 2 dx, then what we're going to have to do is multiply by 2, divide by 1/2. So we're going to have to multiply by another 1/2. So we're going to have that out in front. And then this is going to be e to the u du. So this becomes a negative 1/4. And then when we take the antiderivative of that, that's just going to be e to the u. So it's going to be e to the 2x. And now this one, this is the indefinite integral. So then we have to add our plus c. And now we're going to bring this all the way down here. So we have x e to the 2x all over 2. So then our final answer is this whole thing, this 3 pieces, x times e to the 2x over 2 minus 1/4 e to the 2x plus our c. Okay, so it's not necessarily nice looking when we're done, but we can integrate it, whereas this one we cannot integrate, just as it is. Okay, all right, so let's stop there and we'll come back for some more.